In this short video, we're going to introduce some concepts that we'll be using in day 8.5. In day 8.5, we're talking about things called parabolas. And parabolas are a unique shape created in the coordinate plane when we graph certain types of equations. Okay, so I want you to follow along on your own paper here. There's no special notes you have to use, just use your own paper to follow along. Okay, so this is our day 8.5 intro to parabolas. Okay. So a parabola is a U-shaped curve, and anything that looks kind of like this when we graph it, or it might be upside down like that, that's called a parabola. And that always comes from some equation kind of like this. If we had A equals ax squared plus bx plus c, and this is called standard form of a quadratic. Okay, this is a quadratic equation, a quadratic function. Anything in that form is going to give us a graph that looks like this, called a parabola. Now, we're going to be looking with some of the graphing and things later on, but one of the skills we need to work with in these kinds of equations is the ability to multiply terms that are considered binomials. And so you might see, instead of your equation looking like this, you might see that equation look something like this, where I have parentheses, x plus or minus some other number times another parentheses, x plus or minus another number like that, okay? And this is called a multiplication or a product of binomials. Okay, binomials are these two-term expressions. Okay, so we're just going to work through some examples of how to multiply binomials, because we're not going to actually leave things written this way. We're going to turn them back into something like that. And it's something that you guys have done before, probably, but I wanted to remind you of what that looks like. So here's our examples. Okay, so your instructions are just to multiply. All right, so the first example, we have something like this. Parentheses, x plus 2, parentheses, times parentheses, x minus 4. We're going to multiply those two together. What we have to do here is realize we're going to take both parts of the first parentheses times both parts of the second parentheses and combine all our like terms. We do this through distributing. We're still using the distributive property, but we're not just distributing one time, we're distributing twice. We're going to take this first term and multiply by both of these terms, and we're going to take the second term and multiply by both of these terms. And then we're going to combine all of our like terms. And you guys might remember doing something called FOIL, okay? First, outer, inner, last. And we've done that before, and that's kind of what we're doing here, but you're really just distributing. So when I multiply the first term times the first term, x times x, I get x squared. Then when I multiply the second term, or the first term times the second term, or the outside terms, x times negative 4, x times negative 4, that is a negative, sorry, not a positive. That's a minus 4x. Then when I now move on to multiply this 2 times both of these, 2 times x, the inside terms, is a positive 2x. And then finally, 2 times negative 4 here is a negative 8 or minus 8. And then we just want to combine our like terms. We're adding all of these results together. So we're going to look at our like terms. You'll notice these two terms are considered like terms because they both have just x. You cannot add the x squared to those because it doesn't have the same exponent. So when I add these two terms together, negative 4x plus positive 2x is negative 2x. And then I just bring everything else down. So the first term is x squared, the last term here is minus 8. And that would be my final answer for multiplying those binomials. Okay, so we're going to practice some more of that. Okay, another example. We'll take our first parentheses as 3x plus 4, our second parentheses as x plus 2. Okay, so again, we're going to distribute the first term 3x times x, that gives me 3x squared because we just do x times x. Then we're going to distribute to the last term there, 3x times 2. We can multiply the 3 times the 2 and get positive 6x. Now we're going to take this positive 4 and multiply by both terms. So when I do 4 times x, that's a positive 4x. When I do 4 times 2, that's a positive 8. So once again, I've got like terms in the middle here. 6x plus 4x combined to give me 10x. And everything else just drops down. Plus 8 at the end, and 3x squared at the beginning, plus before the 10x. Okay? Let's keep working and try another few. Let's do another example. Let's say I gave you this set. N plus 2 times n minus 2. So sometimes it's not x's, sometimes it's different variables. We're still going to distribute our n at the beginning to both of these terms. N times n is n squared. N times negative 2 is minus 2n. Then we're going to do 2 times n, so there's a positive 2n. And then 2 times negative 2 is minus 4. When you combine these like terms in the middle, though, negative 2n plus positive 2n is 0n. So we just don't write that. They cancel each other out. So the only thing I have left is n squared minus 4. So we get some special cases sometimes like that. All right, let's do another couple examples. And these are going to look a little different, but I'll explain how they're really the same thing we've been doing. Okay, number 4 here. You're again multiplying, but this time it's parentheses x plus 6 parentheses squared. Okay? Now, I want you to understand something. This is not equal to x squared plus 6 squared. You can't do that. That's not okay. That does not give me my answer. That's not the right thing to do. It does equal the parentheses x plus 6 times itself. Okay, when you square something, you're taking it times itself. So we can't distribute our exponent into something that's added or subtracted like that. So now I can do this the way I've been doing these. I'm going to take x times x, which is x squared. Then I'm going to do x times 6, which is plus 6x. Then I'm going to do this 6 times x, which is plus another 6x. And this 6 times 6 at the end would be positive 36. Now I can combine my like terms in the middle. 6x plus 6x doubles that to 12x. I bring down the plus 36 at the end, and I bring down x squared plus at the beginning. Okay? So as we keep moving forward, one more example here. You might see something like this, x minus 4 parentheses squared. Again, that doesn't mean we square each of those individually. It means that we take that x minus 4 times itself, okay? We're going to distribute x to both, and then distribute negative 4 to both. I want you to try this one. Pause the video if you need to. Try this real quickly and see what you get. All right, if you need more time, keep it paused. Otherwise, this is what we should get. When you do x times x at the beginning, we get x squared. X times negative 4 is minus 4x. Then this negative 4 times the x here gives me another negative 4x. And at the end, negative 4 times negative 4 gives me positive 16. So remember that negative times negative is positive. Now I'm going to add these two in the middle to equal negative 8x. Bring down your plus 16 at the end. Bring down your x squared. There's already a negative, so I treat that as a minus. And that's my answer. So this is a skill you're going to need to do. You have a chance to practice this with a worksheet now on just multiplying binomial expressions. You're going to get a lot like examples 4 and 5 because that's the most the most useful thing we're going to do with lesson 8.5 is in that lesson, you'll see where we do some things with expressions written that way.